Scheiße!
Hello, welcome guys to Sonic the Hedgehog and the third video today. Hallelujah, I have nothing to do and I'm just filming videos about stuff that I wanted to film quite some time ago, but, well, truth be told, I'm finally getting to it. So the second small project that I'm showing off today, by the way, this right here coincidentally is the Sonic Wash 3000 Mark III. It's a CNC washing machine powered by a diesel engine. I'll make a video about that someday. But what I'm making a video about today is another one of my small projects, and it's this thing right here. You might be thinking, oh, a small ominous cardboard box. Let me tell you that this is let's open it up. Check it out. No, it's not a tiny computer. I mean, it could be classified as one. I mean, the processor in it runs at 27.255 megahertz, but it's definitely not that. This is a tiny little video receiver. And what kind of protocol does this use? Well, it uses RF-COM, and let me tell you something. RF-COM is, I've got a book about it. It's English. It's just a theory, but I've sort of taken snippets out of the book and used it to build the circuitry in this, and trust me, it's genius. But I'm going to show you how it works later. I bought that book in like a antique bookstore close to here, and it's pretty interesting. But this thing is basically a receiver which uses RF-COM, which is something between an analog and a digital video transfer. We'll talk about that later. It does audio and video. So if you look at it, it's pretty neat. It's a little laptop. It's in a cardboard case because I'm waiting for the case to be actually made for it because it's going to be titanium. So this thing is pretty neat. It's got 1080p resolution. It's also got, both of the displays are electroluminescent. The display down here is a status display. It's a green display which shows you the tuned-in carrier frequency, the tuned-in sub-carrier frequency, the signal strength, view meters, battery level, clock, time and date, yada yada yada. It's also got a keypad to control it, which is just a prototype. Got the power button. You've got the volume buttons, and this thing is, well, I'm gonna show you more once we get down to the bench. But this thing, first of all, is meant to be powered by a battery pack, which will clip on the back. The battery pack is going to contain a 1000 mAh lithium-ion cell, as well as a USB-C port and a charging and appropriate charging circuitry to charge it. It's also going to have a headphone jack as well as a HDMI converter in it. And this thing is, first of all, it's a massive, gross hodgepodge of various different components inside. And let me tell you, there are almost no modern electronic parts in here. The only modern parts are the displays, the speakers, and the cooling fans. Yes, this has got two cooling fans in it, believe it or not. It's got two laptop cooling fans, one in the display, one in the bottom part. And it's a hodgepodge of various different parts all the way from the 1950s to the 1990s. So trust me, don't hate on me. It's a massive hodgepodge inside. But there's some neat stuff in here, and I'm going to show you how it works. And again, because I'm definitely afraid to show schematics of anything I build because of the YouTube channel termination wave with their stupid AI. I'm only going to show you the theory of operation and what's on the inside. I'm not going to show the schematics. And you know why I'm not showing you the schematics? Because I'm secretive. I don't want to show you the schematics because I don't want people hating on me. Hey, you're making total bullshit. You're such a dumbass. Your project sucks. I'm here to just show you that. I'm not here to hear that that I'm an idiot, my projects look ugly, my projects suck. I'm just here to show you what I'm building, okay? So, if you're gonna hate on this video, I'm just gonna straight up block you on this channel. I don't give a shit. Like, I'm not here to receive hate. I just want to show off my project, so if you say something really ugly, you're not welcome here. But, anyways, that's it for the rambling. So, let's get down to the bench and let me show you how it works. So, welcome on the bench, and let's have a closer look at what is called the µCOM. So, here it is. It's, as I said, in the form of a tiny laptop. Stupid fucking office chair. It's in the form of a tiny laptop. And let's first of all have a look around this. Then I'll open it up and show you how the circuitry looks. And then I'll get down the notepad and I'm going to show you how the whole thing is built. And I'm also going to put up some pictures on the screen of photos I took during the assembly. So yeah, let me get my pointer. It's already over here right next to the PC. No, next to my laptop. So, come on, for fuck's sakes. Stop hitting the chair. Or the tripod. So, let's have a look around it. So it looks a little something like this. So this on the back is where the battery pack will go. This is the little holder for the screen. Down here is going to be the intake for the cooling fan. Main cooling fan. And on the side here is going to be the exhaust for the main cooling fan. And if we open it up, it's in two parts. We've got the monitor part, and we've got the main sort of receiver part. So on the bottom here, let's have a closer look. We've got the status display, which shows the tuned in carrier frequency, sub-carrier frequency, all the stuff I said in the beginning. You've got a power button. Right here will go a menu button. Then we've got volume buttons, plus and minus. Down here is a sort of control keypad, which is pretty simple. It's a Schneider keypad. It's pretty genius. You've got function buttons, and then if you push shift, it changes over to an alphanumeric keypad. You've got up, down, left, right, shift, enter, delete, shift, and escape. And up here's the main display. So now, let's pop this open, and I'm going to start off with the monitor. Let me just take this out. And this is the monitor. So I'm going to actually bring the tripod down slightly so it's not in the way too much. Okay, and let's just twist this up like so. There we go. So this is the monitor with its driver PCB and the display. So the display itself lives under here. Next, over here is the driver PCB, and then over here is the cooling fan. And it's a TNT, not the explosive, T and T. Fan, its model number is 4510M05F. It's out of an old MSI. It's out of an old broken MSI netbook. It's 5 volts DC at 280 milliamps on startup. Quality and performance. Truth be told, this fan is actually quite high quality. This over here is just a little discharge duct I made out of Kapton tape. And this fan spins, and it sucks in air through the back, blows it through this duct and blows it across the display to cool it, and then it comes out the bottom because electroluminescent displays, they get hot. Then over here is the driver. So the main heart of the driver is a Tesla IC, which is designed to drive. I don't know if this is even the same one. I think it is, because it is out of a device which had this in its monitor. I think it is. I can't find any info about it on the internet, but I think it's the driver used for the display. And it's pretty smart because it can do high resolution and all that kind of stuff. And it's got its in this nice ceramic package with the gold top. It's got the reference crystal. It's a GTE West German thing. It's West German. It's made in the 39th week of 1984, and its frequency is 4,433.619 kilohertz, which is 4.433619 megahertz. It's slightly over, almost 4.5 megahertz. There's just some resistors. There's a germanium diode. These vintage West German dark red resistors. We've got these old Allen Bradley carbon composition resistors. We've got a photodiode used for dimming the display. Over here we've got some more germanium diodes. We've got a resonance capacitor for that crystal. There's a bunch of transistors here. This potentiometer right here, this trimmer, is used for adjusting the bias voltage. There's an output capacitor. There's a metal can transistor. As I said, I'm not gonna explain the circuit because I'm definitely afraid of my channel getting terminated. And over here, this right here is the inductor used for creating the voltage. And how this works is, first of all, there's these old ITT germanium silicon diodes which have gold-plated legs. Check that out. But this right here is the inductor for the boost converter for the LCD bias voltage, and this transistor in the middle of it. And no, it's not a special bumblefuckery where that inductor induces a pulse in a Hall effect sensor and yada yada yada. It's just a transistor sitting in the middle of the inductor to minimize the circuitry down to a pretty small space. And after this update, iPhone cameras don't stink in focus anymore. But this transistor switches this inductor. Then there is a resonance capacitor, rectification diode. It goes to the display. As simple as that. So that's all I'm going to show you on this board. Kind of a closer look at what's on here. So now, let's put this aside. Let's dismantle the main unit. So this comes off, you flip it out these flaps, and oh my god, here it comes. Get out of my way. Okay, well, that's the cooling fan on the bottom, but oh, fuck. You see this, right? This is just perfection. Bumblefuckery perfection. One moment, please. Oh, I thought the window wasn't closed. It is closed after all. So let me show you what we got here. So first of all, on the bottom is the main chassis cooling fan. That's used for cooling off the high voltage demultiplexer. And this fan spins, sucks in air through the bottom, then blows it out through another duct made of Kapton tape, then blows it through the high voltage demultiplexer PCB, no, demodulator PCB, and it just blows it straight out. So stuff I'm going to show you. We got 4 PCBs here. This down here is the high voltage demultiplexer PCB. Then our next to it is the signal PCB. That's the only PCB I got a photo of. I'll put up a picture on the display right here for what that is, how that looks like. And then right above here we've got a control PCB for the high voltage power supply, and then up here is the main motherboard. It contains the signal processor, the second stage demodulator, plus the main processor. And let's explore what components we got on here. So I'm going to show you closely what we got on here. So starting on this side, this over here is the switching transistor, Soviet one. It's a KT863A switching transistor for the high voltage transformer, which is hidden right behind there. It's also a neon bulb hidden there as well with it. We've got 3 germanium diodes, one here, one behind here, and one hidden behind there. And that little gray or brown part you see right there is the modulator. This over here is the resonance capacitor for the primary winding of the transformer. Then over here we've got some of these old, very old ceramic capacitors. This is an SHM, now KCK capacitors. That screams 1960s clock radios. It really does. These are in every single kind of Taiwanese or Japanese or any kind of clock radio, and they are just the staple of any old circuit. That's why I use them here. Next, we've got some components interconnecting the 2 PCBs. We've got we've got some resistors, some West German resistors, these green ones. And one thing I hate blue resistors. I like the tan ones, the green ones, and the red ones. Other resistors, I don't like them. So this over here is one. So I'm gonna try to color code resistors. So this one right here is green, blue, yellow, and gold. That's a I believe that takes down. That's actually what's responsible for controlling the voltage, or that's a voltage feedback. You got 2 of these old Solvay germanium diodes. Those are high voltage feed loop. Those are feedback of the IC to control some of the transistors in here too. That's a part of the signal circuitry on here. There's some signal circuitry on here. There's 2 transistor simple amplifier. This is a part of that. Another germanium diode over here, again a part of the amplifier. And then we've got more resistors. There are 2 of these, and these are yellow, violet, yellow, purple, red, and gold. And this one over here is blue, gray, brown, and gold. So that's what that is. There's some more of them up there on this PCB, and there's these very fat, old, Polish resistors. And on this side is some of the more stuff. This over here is the reference crystal for the high voltage power supply. This over here are the 2 resistors which actually output a part of the signal, feedback the signal from the third IF stage back to the high voltage power supply control, back to the back to the amplifier on here. We got a coupling capacitor, some more germanium diodes and resistors that's used for controlling the IF pitch, I believe, and all of this stuff. Then we've got another germanium diode behind here. We've got another coupling capacitor right here, of course a KCK. That one's a West German one. Then we've got the main clock crystal right here for the system. That's a 27.255 MHz crystal. These vintage Czechoslovakian ones, they aren't welded together, they are soldered shut. That's what I like about them. Those 2 germanium diodes you see behind there, one is right there, one's behind this capacitor. Those are the detector diodes for the detector transformer. And again, I'm gonna put up a picture on the screen of the signal PCB where I'm gonna show you, well, where you can basically see what that looks like. It's a mess. It really, all of those boards, as you see on the screen, all of the boards down here look like that, except for the top ones. Those are just low profile. The 2 bottom ones look like that. It's just a ton of components in one place. I really crammed a lot of this stuff into a very small space, and this is what it looks like. Components soldered between the perf boards because, you know, space reasons. This over here, this RF diode, is actually a signal feedback to the signal processor straight from the output of the detector. These 2 germanium diodes are part of the demodulator circuit. This is another couple. This is a filtering capacitor right here. This right here, this resistor is a feedback of the signal strength on the IF SAW filter stage. The IF SAW filter is right there. These 2 resistors actually carry the signal up from the discriminator into the signal processor. And this one over here carries this one with the color code red, purple, orange, and gold. That carries the audio, and this over here, yellow, purple, red, and gold, that carries the video signal. And the discriminator is over here. It's built of 2 transistors, and there's also a sub-carrier crystal in there as well. And you can see that this section is built of these very old Japanese resistors, these fat half-watt babies. They really look cool. And on this side is where the mess is. This beautiful crystal in a glass case is actually the crystal for this is actually the reference crystal for the signal processor. Very high precision, this thing. I can't remember the frequencies on the sticker on the other side, but it's very high precision nonetheless. We've got these old capacitors. There are some of these. There are old blue capacitors. You can see one right there. There are light blue ones in there. You got these old gray ones. This is actually a sound ace capacitor. And if you look at it, just to show you how old it is, look at the rating on it. 1 microfarad, 10 watt volts. When is the last time you've seen watt volts on capacitors? It just really shows the age of this, you know, age of the components in here. This already is the transistor for the local oscillator. And then this network of components is again a part of the high voltage power supply. I won't go too deep into that, but this over here is a beautiful Soviet germanium diode. There's also another neon bulb up there. That's a protection device. Then these two resistors actually carry the signal out of the high voltage demodulator. These two ones. Now here's the local oscillator. Behind there is the mixer. The mixer and the filter stage contains very special transistors, very special old Polish transistors. Those have a gray silicon K. Those have a a gray package and gold-plated legs because they're special RF transistors. So that's what those are. And then next there's a coupling capacitor right here that's used for signal strength measuring on the filters. No. That's a signal feedback from the from the mixer stage. Then this over here is the signal strength meter. This inductor right here actually carries this signal out of here for the signal strength meter. This over here is again a part of the filter stage. I really cannot remember now. It's quite long since I built this. It's like half a year since I built this, so I can't really remember out of the top of my head. But that's all you'll see in the bottom here. So now it's time to show you. I'm gonna get out the sketchbook. I'm gonna put these laptop fans out the way, and I'm gonna pull up the sketchbook. Also, incidentally, if anyone's wondering, the cooling fan on the bottom of here is a Delta model KSB 0510 05105 HB, 5 volt DC, 5 volts, 320 milliamps startup current. So now I'm gonna get out the notepad, and I'm gonna show you how the circuitry works. Okay, so welcome to the notepad, and I'm gonna show you. As you can see, I have some drawings here. I'm going to show you how this looks. So here's all the drawings of all the boards. So first of all, this is the monitor part we took a look at. And if you look, this over here is the, I'm actually going to try and zoom up now, is the cooling fan. That's this part, and this is the driver PCB. That's this part. This over here is the reference crystal, the driver IC, and the bias PSU inductor. So now, let me show you how this works. So this is the drawing of all the boards from all the sides. So these two boards are the two bottom boards on here, meaning this one and this one. This is the high voltage demodulator PCB, and this is the signal PCB. The signal PCB looks a little something like this, showing you the third time. I'm gonna put it up on the, gonna leave it on screen here for the whole time. And this over here is the high voltage demodulator PCB. This is the signal PCB. This is the control PCB for the high voltage power supply, and this over here is the main motherboard. So the control PCB for the high voltage power supply is this one at the top here, and the motherboard is this one at the top here. On the top of the motherboard is where the main processor is located. That's that right there. And it contains everything. It contains the entire computer, the audio amplifier, all the decoders, plus all the necessary drivers. It contains everything. It's a special ASIC from back in the day. Then on the bottom, so this is the bottom view of the main motherboard, and that's what I'm going to show you. So let's see where it starts. So the signal from the antenna comes on here, and the signal from the antenna connects onto, let me show you, signal off the antenna from the antenna connects onto this very resistor right here, onto this very resistor, and then the signal comes in. Now that's where the antenna connects, and the antenna is going to be in the monitor right behind the cooling fan. And if you don't know what an antenna is an electronic device used for converting signal waves into voltage. And if you an antenna, don't think like I said it's an electronic device. Don't think it like contains transistors, diodes, resistors, capacitors, inductors. It's dead simple. If I say it very simply, it's just a piece of wire. That's what it is. It's just a simple piece of wire. And how it works is the signals basically, you know, the wire, the signals goes into that wire. The signals induce an electric field in that wire, and no. One more try. The antenna is effectively a piece of wire, and the electromagnetic fields, the waves in the air, induce a voltage in it, and that voltage is the signal corresponding to those radio waves, and is then sent into circuitry to be decoded. As simple as that. So everything starts over here. The first place it goes is a simple RF amplifier, just 2 transistors. Then it winds up at the high voltage demultiplexer. That's this part right down here. And then we've got a high voltage power supply right here, driven by this transistor right here, and it's got this resonance capacitor right here. And it provides 600 plus volts to drive the drive the high voltage demultiplexer. Plus, it's got a commutation neon bulb in series with the high voltage power supply, just to limit the current, I guess. It was in the schematic of the part, so who knows. Then you've got the 3 germanium diodes in there. Again, on the PCB, one is in there, one is hidden behind there, one is hidden over here somewhere. Those are a part of the signal circuit. So then the circuit comes in, and the high voltage demodulator removes all the noise from it, removes all the unnecessary crap and harmonic content we don't want, and that conditioned signal then gets sent into the signal board. The signal board is this PCB right here, and again, it's on the screen right here. How the signal board works is it goes into the signal contains into the mixer. Then you've got the local oscillator over here, which is the red IF transformer, and that's tuned by tuning the carrier frequency. If you've got a radio and you know that scale on it, when you turn the knob and it varies the scale, that varies the carrier frequency. And this gets sent to the mixer, and also the signal from the demodulator gets sent into the mixer. What happens there is the signal going into the demodulator is just a mess. It's a hodgepodge of all the channels you want to watch, all the crap. And what this does here is the mixer takes in the signal, and the local oscillator basically takes in its own frequencies, tuned to the frequency you want to listen to. So the carrier frequency on here gets sent into here, and the carrier frequency of the signal is already present here, of the signal you're receiving, and the frequencies effectively cancel them out. So then it's the mixed signal coming through. It's the mixed signal, basically cancelled out carrier frequency, is the signal coming in. Then it goes through an IF SAW filter removed from an old TV that filters it further. Then it goes into, well, first of all, let me show you. The local oscillator is hidden right behind here. The mixer is right behind here, and this over here is the IF SAW filter. Then it comes out of that, and it goes into a 4-stage IF amplifier. The first stage has got a green IF transformer, the second stage is adjustable for reasons. I had it adjustable, but it turns out when you turned it by like a nanometer, it would all go out of tune, so instead used a non-tunable transformer, which was the correct kind of ratio. So that's the second stage, then it's the first stage, the penultimate stage, and then the fourth or the last stage. And then that's the signal amplified enough so that it can be worked with in the signal processing. Then it goes into the detector, which is used to lock on the signal you want to listen to, and it just filters out all the other unwanted crap. Then it goes into the discriminator, and there's the subcarrier crystal. And how this works is, you've got the 2 audio signals, they're effectively glued together. Imagine them like the audio signal being one piece of the wood, and the video signal being the other piece of the wood, and the subcarrier frequency is what is the water-soluble glue behind them. And the subcarrier crystal, along with its subcarrier circuitry, and the 2 transistor separator, basically injects the subcarrier frequency, which is constant, into in between the wood. It's like injecting the water into the glue. And that water dissolves the glue, and you can then separate the 2 pieces of the wood. That's what it does. It injects the signal, and it separates the audio and video signals. Once that is separated, it's sent via these 2 resistors up into the signal processing circuitry. First place it goes, this is the signal processor. That does all the stuff. It takes in all the feedbacks through all those resistors from all the parts of the signal circuitry, plus the high voltage demodulator circuitry. And it just sort of hodgepodge combines them and works with it, and it creates a sort of signal which can be worked with. And then it also uses a reference crystal so that we can work accurately. That's this beautiful glass packaged crystal right here. And Then the signal out of that is sent back to the second stage final demodulator IC. And that's where it gets finally demodulated. That's where it gets turned into the signal that the main processor over here can use. And the processor then converts that signal into the composite video signal. And that's then sent up to the monitor. Boom! We got video. Next, we got the main clock crystal for the processor. Right? The processor is up here. This is the clock crystal. And boom, coming out the processor is composite video sent up into this. Now, that's not the only thing that the processor does. The processor also... Oh, fuck. The processor also acts as the audio amplifier, so it amplifies the audio and sends it into two speakers. Now, there's two speakers behind there. There's a small one, that's the signal, that's the system speaker, and the big one on the here is the main audio speaker. And that does it. Now, it sends the composite video to the display, but it also does one thing, and it acts as a software. This thing's got a software in it, and that software contains a bunch of functions. You can enter in a channel number. You have various different settings. You have got a clock and an alarm clock. Pretty ironic considering the last video I made about an alarm clock. It contains a bajillion other functions you could find in a computer. That's what that does. Now, we're basically finished with the signal circuitry, and then we travel up into the monitor. And the composite video signal is sent into the driver chip. Then the reference crystal is along with that for the proper signal decoding. Then we've got the bias power supply, which generates the bias power supply for the electroluminescent display. And then the chip just basically converts that into the signals we want for the display, drives the display, and that's how the video is shown. And the bias voltage, of course, is the bias voltage, and this is the driver. It's basically the power supply boost converter over here. It's tunable right here. You can change the voltage. That changes the overall color balance of the display, so you have to tune it exactly to have the kind of correct color balance you want. But well, so it takes in the video signal, uses the reference crystal, it converts it to the signal we want, and then it's just basically sent out to the display. However, this photodiode is used in conjunction with that crystal, and it's used as a sort of diode. It's a compensation diode with the crystal, essentially, and that's why when you take this apart, when it's working, the display will go, oh, catty wonkers. And there's also the resonance capacitor in conjunction with that crystal to make it run more accurately, of course. And then there's just a bunch of remaining dots. That's the signal circuitry. That over there is the signal amplifier, that little transistor, and that's it. And then we've got the cooling fan, which just cools the display so it doesn't overheat. We got the cooling fan in the bottom, which cools the high voltage demodulator so it doesn't overheat. And boom, that's it. So that's the whole system. That's all I have for you. So now let's put this back together and finish the video. Okay, so that's it for this video. That's all I have for you today. So I've shown you off the second one of my small projects, which is this little transmitter, and I sincerely say some of this might be complete nonsense. Again, I've kind of been sucking this out of my finger, you know, trying to come up with a sort of receiver which could work with RF-COM. However, as said, it doesn't even have to work. It's just a little bit of a prototype, a little bit of fun I had, so please don't hate on this project. Be polite, okay? Be professional, don't be an asshole. But that's it I have for you today. So I've shown you everything about this. I've taken it apart, show you all the stuff, explain how it works, and that's essentially it. So I hope you liked it. Hope you learned something new, and I'll see you guys in the next one. Bye-bye.